University of the West Indies, Faculty of Science, specifically the Department of Mathematics. And we do hope that you enjoy the session this afternoon. We thank you so much for coming. Just in case your friends should be here and they are not here, please just give them a call, send a message to them and let them know that we have started. Now, as usual, I'm going to give shout outs as what I have been doing over the past 2 weeks now. And shout outs are going to Kingston Technical High School, Edwin Allen High, Claude McKay, Garvey Maceo, Clarendon College, St. Thomas Technical High, Harrison Memorial High, Immaculate Conception High, the Queen's School, Alphonsus Davids High School. We also had students from, I did say Garvey Maceo before. We had students coming from Edwin Allen, yes, St. Thomas Technical. So we did have students coming right across Jamaica, Claude McKay High, Greater Life Academy. And we want to say kudos to you for staying with us so far with all these sessions that we're doing. St. Catherine High, yes, we know you're in the house. And please remember, even Knox College High, we had attending our session on Tuesday. So please remember, post the name of your school in the chat so that I can give a shout out next Tuesday when we will be here, same time, same place. Dr. Kirk Morgan, he is currently experiencing some technical difficulties, and as such, his camera will not be on for the entire session. He was on earlier, but to save on bandwidth, yes, and some feedback that we're hearing, his camera will be off. Dr. Morgan, over to you.
Thank you, Mrs. Johnson-Burrell. Good afternoon, everyone. Okay, welcome again to this other session, which is part 2. And we did part 1, like she said, on Tuesday. Yes, the 28th of April. Okay, so we're going to do our first question on functions. So here's that you're given a table. So it gives a function, f of x, which equals 3 plus 2x minus x squared. And we are given some of the values for the different x values. But we have to find the 2 missing values for the number x equals minus 2 and x equals to 2. And ladies and gentlemen, whenever you're doing the question in the exam, please pay close attention to the actual mark that is allotted. And that will tell you how much time you're supposed to spend on the question. Don't waste time. And if it's just 1 mark, then you know that you cannot spend too much time. All right, so we're going to substitute now the values of the x in the table, and we're going to get the f of x values. Okay? Now we can call f of x y. So what you're going to do firstly is that when x equals minus 2, we're going to substitute minus 2 in the function. So we go to, because all the other values are obtained, they actually replace x by those numbers. When x was 0, they got 3. When x was 1, they got 4. So we're going to substitute accordingly. So when x is minus 2, we replace minus 2 in the actual function. So you're going to replace, anyway, say x, you replace it by what? Minus 2, so it's 3 plus. But don't forget, ladies and gentlemen, whenever you're substituting a value of x, don't forget now, put a bracket. So it's 2 times bracket, right? 2 times. We're going to multiply it by minus 2. And then now, after that, they're going to subtract now. But it says negative, so be careful now, negative. Because we have a minus sign, we're going to have a bracket again. We're not going to put the minus minus. We don't want the 2 signs to meet like this. No. Don't put minus minus. X is minus 2. Because what we have in the expression is 2x minus x squared. So minus goes as was. Then because we're going to replace x by minus 2, put a bracket. So once you replace the value of x, always put a bracket. Then you put minus 2 in the bracket and you square that. Okay? I want that to be a square, that should be a square. And the rest is really algebra. Okay, what will be the answer now? Let's see now what will be the answer. We're going to get what? 3. What is minus 2 times 2? Guys, we're doing now normal algebra now. So functions, although, it has involved in algebra, so not because we're doing functions. We're going to have the grassroots, which is algebra. So every time you have a topic, you might have to use a different topic in that same topic. So you have to make sure you understand every single topic, okay?
I am seeing Sweden in the chat saying 4. Students, remember you can open your mics.
Oh, yes,
right.
right.
You can open your mics.
So because I'm not looking at I'm not reading the chat.
That's
I'm not looking at the chat.
That's fine,
right.
sir.
Thank you for telling me. Yeah, right, guys. Just like Mrs. Johnson said a while ago, you can always talk about the answer. Is it -4 or 4? What is the answer? 4 or -4? What is 2 times -2?
Well, Sweden has 4. So the others you can open your mic, students, and share with sir. Minus. So she changed it to -4.
Right, -4. Very good. No, and what is -2 square?
-4.
Right, very good. No, wait, no. What is -2 square? No, what is -2 square first? Don't tell me the final answer. What's -2 square? I'm asking you.
4.
4, but because the minus sign was there, put back the minus sign first. Because if you realize, we have minus, which was there before, but we are squaring -2 now, we get +4, so you must have +4 is -4. Why? Because when you square -2, we get +4, but the minus was there in front of the bracket, and that have to go back first. Don't forget. Yes, so that's how it works. Let me remind you about something, guys, in case you forget. Watch carefully. If you have negative of, say, -2 all square, the answer is not 4. The answer is -4. Because the minus that was in front of the bracket must be written first. Then when you square -2, we get +4. So the final result is to be -4. Don't confuse, guys. Don't confuse this now. If you have -2 like this by itself, that will now be +4. That will be 4. Because don't forget it, that's common mistake making algebra. And one more thing I want to bring to your attention. If you have, say, -2 square, now you have to be careful to write your sign. Because is it that we are saying we are squaring 2 or we are squaring -2? You have to be careful. If you are squaring only 2, guys, listen carefully. If you are squaring 2, then the answer would be what? It would be -4. Yes, that's how it works. If you are squaring -2 now, show that the bracket show that it's squaring -2 like that. Then this is now be 4. So I think you should take a picture of what I'm saying. Note for me. I still complete the final answer for what we're doing, but I thought I could stray a little to show you the mistake that are commonly making in normal algebra. So take a picture of that for me, please. A note for me. All right. So you have to be careful when you put the minus sign on the bracket. All right, cool. All right, let's now bring it to this conclusion now, ladies and gentlemen. Now, so having said that, then therefore means that. So let's go in the next line. All right. We had it here already. Okay, we had it here already. Okay, what is 3 minus 4 minus 4? Who could tell me? What is 3 minus 4 equal to?
5.
Excellent. Well said. Oh, 5 or -5?
-5.
Okay, -5. Everybody say why -5? Because -4 minus 4 is -8. So what I normally do, I normally group the numbers that have the same sign first. Because 2 numbers can only be added together if they have the same sign. Come again, guys. 2 numbers can only be added together if they have the same sign. What does that mean? If both numbers are both positive, we add them and keep the positive sign. If they are both negative, we add them and keep the negative sign. If they have 2 different signs, we subtract the smaller number from the bigger number, and the result tells the sign of the bigger number. So initially we had 3 minus -4. So what we have, really and truly, ladies and gentlemen, before I put the final answer, we should really have 3 then. So -4 minus 4 is with a -4 plus -4, which is -8. Right. I hope you know that. That's what I did. -4 you don't need to use calculator. -4 minus 4 is -8. Why is that so? Because one thing I have to bring the attention again. Because if for instance, if I have, say, A minus B is the same as A plus minus b. It means the same thing. So if I have minus 4, for instance, in particular, minus 4 is the same thing as minus 4 plus minus 4. Everybody appreciate that? Everybody appreciate what I said a while ago? So we end up getting minus 8. Okay, and then I haven't done that now, so we have now what? We have 3 minus 8, which is just what? Minus 5, and that will be the answer. All right, let me just erase this part here. So guys, don't take this thing for granted. You know, you have to remember these things, okay? Because these things come back to haunt you. All right, okay. I don't want to waste time erasing this thing. But so the table should have now for the first value when x is minus 2. So you're gonna in your exam you'd have actually replace it by, it should now be what? Minus 5 would be that answer right there in the bracket there. All right, but I appreciate that. Cool. Now when x is 2 now, similarly when x is 2, we're gonna replace 2 now again. So we're gonna just substitute 2. So like I said, guys, you have to move very fast. Don't waste time on unnecessary stuff. Don't waste time. When x is 2, what do we get now? We get f of 2. What is f of 2? It is 3 plus 2 times 2. Yes, minus. Like, ladies and gentlemen, don't take this in for granted. You must always replace it in a bracket. Don't forget the bracket. You know, whenever you're substituting a value of x, put it in a bracket for convenience. And the rest now we're now doing directed numbers or algebra, a part of algebra. What do we get? 2 times 2 is 4. And minus 2 square, which we already established that minus 2 square is what is minus 4. Is not 4. We are squaring 2. So the minus must be written first. We're not squaring minus 2, we're squaring 2. 2 square is 4. And the minus was there in front of it. So what is 4 minus 4? We get 0, right? So it's 3 plus 0 equals 3. Okay, and so you put in missing value there, it'll be 3. Why is it not going in? Oh, okay. So those are the two values we just found a while ago. Everybody saw where the two numbers came from? Good to go? All right.
Yes, sir.
All right, very good. Okay, you can take a picture for me quick. Please transcribe for me. All right. All right, let's move on to the next one now. Okay, so it's the same question now, but now having found the two missing values of x, I mean not of x, I mean not x, I mean of y, which is the same as f of x. Having found those two values that we're going to compute now the actual graph now by replacing those points. So you realize that they actually did the first, how many points they did first already? 1, 2, 3, is it 5? 1, 2, 3, 4, 5, right. So we're gonna, when x is minus 2, what we got it to be minus 5, and when x is 2, we got 3. Let's plot those 2 points now. So come guys, let me know guys. So minus 2 gave me 5. Minus 2 gave me minus 5 rather. So where's x equal to minus 2? Right here, so. See x is equal to minus 2 right here. So the answer was what? Minus 5. So we go down now vertically. This is the point what? Right here. So would this be my point right here, ladies and gentlemen? Would this be my point? X is minus 2, y is minus 5. Cool?
Yes.
All right, very good. What about when x is 2? What was y again? Y came to?
3.
Yeah, this is where x is 2. Where's y equal to 3? Is it right here? Is it this value right here? That's it?
Yes, sir.
All right, I was supposed to complete the graph. No, I cannot draw my graph here. I don't have a French curve. You normally we use a French curve to draw our quadratic equation. Oh my lord, this is a very, very badly drawn. I'm trying to draw a nice smooth curve. Guys, in your exam, let me tell you what you have to do in the exam. If you don't have a French curve, what you can do, you don't have to draw the graph one time like I did a while ago. My graph needs some caramel porridge. Look at the left hand side of my graph. It needs some caramel porridge. Oh my lord, that's not a good graph. But guys, you can just draw. You don't have to try to draw like say from each point to each point like you're trying to draw a straight line. No, at no point on the curve appear as a straight line, it's going to lose mark in the exam. So what I would do is just take my time and just draw as much as possible. And sometimes some of the points might be left out, but don't worry about those points. Yes, because I might try to draw 2 points and get a straight line. You might go like this to connect 2 points and get a straight line, and you're going to lose mark. So do not do that. So try to see if you can draw freely with your pencil. Just draw freely like you're drawing a curve, guys. Like you're drawing a curve. And try to go through as many points as possible. Or better yet, let me show you which way you could have done it if you don't like that way. You could have started from the top part like this. Come geniuses, walk on, pay attention. You could go like this then, ladies and gentlemen. You could go like this. Some people like this. Smooth. Try to make it smooth. I don't like how mine look at all. I'm using a device which I can't manage properly because I'm having my mouse. My mouse I cannot manage properly. We could try to connect the 2 points, like, you know. Sometimes use a French curve in the exam. You can use a French curve. I think you say I cannot manipulate my mouse. Yeah, my mouse I cannot manipulate my mouse at all. That's why I cannot get a perfect. Anyway, so do it good in the exam. All right. All right. Let's just drag back what I had a while ago now, quick. So just try to go through as many points as possible. Let's see now. Let's try to go through as many points as possible. Let's see if I can go like this instead. I think mine's going to be like a straight line again. I miss it. Yeah, I miss it. Yeah, I'm going to miss that point. So guys, just do it properly, please, in your book. Mine is wrong. Okay, mine is not right. The first one was much better. Yeah, I'm missing my point because I'm using my mouse and my mouse is not really, yeah. All right, so we're going to join every single point as much as possible, okay? All right, let me see what they asked about again. This one, that's all you're supposed to do? Okay, you're just going to connect the points and you get to draw a graph. I'm going to ask you a question, guys. How do I know that the graph should shape that way? Why didn't my graph shape like this? Like a U? Who can tell me why? Why did the graph shape like this? Who can tell me why? You need to know for your exam, you know, the shape of a graph. What determines the shape of a graph? In particular, a quadratic expression, the form of ax squared plus bx plus c. What determines the shape of that graph, guys? Because the graph could have actually had 4 different shapes. It could have shaped like a U or like a cup or a smiley, people say, or a frown. It can shape like this or this. So what determines which way the graph shape? What determines which way the graph shape? Who could tell me what?
Invert.
Look at my example. Ax squared plus bx plus c, which is the standard form of the, what do you call that expression? Quadratic expression. Where the ice is 2. So what determines how the graph shape? Is it A or B or C? One of those are the key elements to determine how the graph shape. Is the A, B, or C determine it?
A.
Excellent. Tell them why. A is called what? A is called the x squared coefficient. What is critical about A?
Yeah, has a square.
No, A is a number and A is a coefficient. In this case, our A is what? What is our A? No, what is our A in our example? What's our A?
Positive.
No, man, look at the example. Oh, it's 3 plus 2x minus x squared. What is our A? What is our A? No, man, no, guys.
X squared.
1.
1.
Guys, you cannot swat, you cannot swat. It's just that the exam are put it in ascending order. But the I score is what is the determining factor. Let's rearrange the expression in the I score in the descending order, the I score. It's minus x squared, which I don't like to write like this. Because I don't like when I have minus sign starting. People don't like to write the minus sign first when a minus start a line. But nevertheless, if I put it in descending order, then we have minus x squared plus 2x. So guys, I don't think you're looking and analyzing it properly because you're seeing 3 appears first. No, not because 3 appears first. Your A is a number in front of the x squared. And in this example, the number in front of the x squared is what is minus 1. That's your A is minus 1. Is it minus 1 in front of A? In front of the x squared, I mean? Not because you don't see a number there. Minus 1 is assumed to be there, but never written. So if you have minus x squared, we really have 1 in front of it, and there's a 1 right here, a 1. So my A is minus 1. Yes. So A determines how the graph shape. If A is negative, the graph bend like this. If A is positive, the graph bend like a cup. Yes. These are the two graphs are different. Those are when what you have a y square, not an x square. That's a y square, not an x square. All right, guys. So everybody appreciate what I said a while ago?
Yes, sir.
Guys, you cannot sweat in. You have to understand the concept. So A tells you if a graph shape that way or that way. Okay, cool. All right. Now, why did the graph bend one time? Who can tell me why the graph bend only one time and not two times? Why didn't my graph bend like this? So even though I'm doing the question, I'll just teach you the concept first, guys. Concept before I do the other question. Why didn't my graph shape like that? Who can tell me what determined how many times the graph bend? What can tell me what determined how many times the graph bend? Why the graph only bend one time? Why it only bend one time? What determined that? Who can tell me?
Because of the square.
The ice power. So everything is about the ice. Everything is about the first term. The first term is key. Because for it to be quadratic, the first term must be present. The ax squared term must be there. We don't have to have the b term don't have to be there, nor the c term. We can only have an ax squared by itself. This is still quadratic. We can have an ax squared term with the bx term. It is still quadratic. We don't have the c term. Or we can have an ax squared term with the c term by itself. It is still quadratic. Or all three terms can be present, which is the ax squared term, the bx, and the c. Because the x squared term is the key. Okay. So if A is positive, mean greater than 0, the graph bend like a cup. That's if A is greater than 0. If A is negative, that means less than 0, the graph bend like a what? A cap. Do you say a cap? Yes, cap. Like a cap. As if A is negative. All right. So therefore, our graph look like that. And because the ice power is 2, the graph has 1 bend. If ice power was 3, if it was an x cube, the graph would bend 2 times. 2 times. All right, I don't want to stray, I don't want to drop the gun. But the ice power is determined by everything. Okay, everything is what the ice power is all about. Okay. All right, let's move on now, guys. So we have to sketch a graph now. Any question before I move on? Any question about what I just said a while ago? All right, let's move on now. Because we have a lot of things to cover tonight. I don't want to spend time on just one thing alone. All right, I don't want to. The reason I don't want to leave this on the writing is that sometimes it is just there permanently. Yeah, when I go back to my document, it's there permanently on my document. All right, let's go. All right. You can always stop me and ask me if I have a question to ask me. Okay, using the graph, we're still on the graph. Determine the coordinates of the maximum point of f of x. So guys, I don't need all of the graph to show this part here now. It's a user graph. So guys, whatever other graph, I just need this part to show you something. This will be the maximum part of the graph. Everybody agree? Like a peak, like a mountain, you go, what's the maximum part of this? Here, maximum. So that's where you'd be standing, guys. You'll be standing right there, right? You're on the mountain, right, guys, ladies and gentlemen? Right, everybody following me? Are you guys hearing me clearly?
Yes, sir.
So like you go to Blue Mountain, the maximum peak. So what will be the maximum part on this graph? Look at it properly. Is it right here, so? Are you seeing what I'm writing? Is it right here, so? Is the maximum part? Or is it right here? What will be the maximum part in the graph? Guys, is the peak is the maximum? Don't is
Sir,
right
1 and 4, sir.
Eh?
1 and 4.
Yeah, that's the answer. Very good. But I want the class to talk to me. Is the maximum point right here?
Yes, sir.
All right, excellent. So the maximum point, so from there you can now draw your vertical line, like you actually extrapolate. You extrapolate to go down, like gentleman said, you go down like this. The coordinates are the maximum, the coordinates meaning you must have an x and a y value. It must come as a pair. So the coordinate is not just one number, it must come as a x and a y value. So the coordinates is when x is what? 1, y is 4. And that's the coordinate they want for your answer. Everybody see that? Everybody saw how I express my answer?
Yes, sir.
Yeah, when x is 1, y is 4. And you can see the graph shows you. Because that's where the maximum point is, okay? So it corresponds to x equal to 1 and then y equal to 4. All right, any question before I move on? All right, that was your part that we just did a while ago. Let's see what they have again right here. We're still on the graph again. Oh, we're still on the graph. It says you must find a range of values of x for which the function is what? Greater than 0. Who can tell me what the examiner is asking us to do? What is they're asking us to do? Do the graph where it's greater than 0. What do you think they're asking us to do? The range of values where it's greater than 0. Ladies and gentlemen, what do you think they're asking us to do, ladies and gentlemen? Ladies and gentlemen, tell us now. Tell us what they're asking us to do. What does greater than 0 mean? All right, every number under the sun, listen carefully now, pay attention. Every number under the sun can be either one of any 3 things. A number can be positive, meaning greater than 0. A number can be negative, meaning less than 0. Or a number can be equal to 0. So if a number exists, every number under the sun, guys, believe me, every number under the sun that you come across in your life, from the day you're born, every number you came across in your life can have only one of any 3 signs. It can be positive, negative, or what? Or 0. If I have 5, 5 is a number. 5 is what? Positive, greater than 0. What about minus 5? That's negative, less than 0. Yeah, and what is 0? 0 is just 0. So I can just tell you what number it is. Every time what, just give me a number and I tell you where it falls. So they're asked now for the range of values of x for which a function is what? Greater than 0. Ah. Come now, geniuses. Come geniuses now, pay attention. Walk with me. Now, the function is called f of x, by the way. You need to know that to begin with. The function is called f of x. That's their function. It's called f of x, which we call y for convenience. Y is equal to the same thing as f of x, right? Now, the range of values of x, what they want, what values of x cause y to be greater than 0? Now, the graph is called a function. The function is the graph. Yes. Because the function is really the y values. That's what form the function. Y values cause the function to exist. When x is that, y is that. When x is that, y is that. And from different values of x and y, the function is actually generated. So now let me tell you what is true now for this question now. Now, listen carefully now. Now, where this is where now f of x, which is y, is equal to 0. Guys, nobody forget this tonight, nobody forget tonight what I'm going to say to you. The x-axis is what? What equation is the x-axis? The x-axis is the equation y equal to 0. But what is y? F of x. Come now, geniuses, walk with me. The student who listens the most learns the most. So on the x-axis, that's where y is 0. And we call the function what? Y. And we call it what? F of x. So on the x-axis, f of x equal to 0. So don't forget the function is called y. Below the x-axis, what is true? What is true about y? Below the x-axis, what is true about y? Y is what? Is y greater than 0 or less than 0 below the x-axis? Come tell me, Genesis. Come, Genesis. Walk with me. Come again. What are the y values below the x-axis? See them here? These are the values, you know. See the y values here below the x-axis. These are they. See them here? Y is -1 minus that part of the graph. You know, see the part of the graph here that was below the x-axis where them y values are negative. See them here now? These are the y values, negative numbers. This part of the graph is below the x-axis. And the graph is called y, or f of x. So this part of the graph that lies below the x-axis is where the function is negative. Because see the numbers here, guys, -1, -2, -3, -4, -5. So those are the y values. Y is what? Less than 0. So below the x-axis, what? Y is what? Less than 0. Now where's y? Where's y greater than 0? Above or below the x-axis?
Above.
Excellent, excellent. So above the x-axis, look here, y is what? 1, y is 2, y is 3, y is 4. And this part of the graph appears above it, see there? See the graph here, it appears above it. So because above the x-axis, y, which is f of x, is greater than 0. Nobody forget this concept, guys. So in your exam, don't forget this concept now. So on the x-axis, y is equal to 0. Same as f of x equal to 0. Can we call it y for convenience? Below the x-axis, y is what? Less than 0. You cannot swat, you have to know why. Because the y is below the graph. The y values are negative. And that part of the graph is below the x-axis. That's where y is negative. Above the x-axis, y is what? Positive. Y is what? Greater than 0. So they want now, let me tell you what they say now. They say find the values of x for which, watch, the function is what? F of x is what? Greater than 0. No, come Genesis, no, walk with me. What part of the graph do they want? Tell me what do they want? Do they want the part that appears below or above the x-axis? Which part they want?
Above.
Above, sir.
Why is above?
Because it's a positive number.
That's where y is positive, right?
Yes, sir.
No, I would say to my students, school is over. The question done. No, school is over. School is over. The question done. Because once you identify the part of the graph that they want, you're going to read off the x values, the range of values of x. For the graph to appear above the x-axis, what values must x have? What values must x have? No, can I tell you what you must always do in exam? The values that x you're going to use in exam is where the graph cut x-axis, where it cut x-axis. You're going to use these two numbers. See there? See them here? Let me erase the spot for you to see what numbers there were. It was -1 and 3, right? -1 and 3. Come again, guys. So you're going to always use those numbers in the exam. Wherever the graph cut x-axis, those are the numbers you're going to use. These numbers will cut x-axis. See them here? So because this part of the graph is what they want, where y is positive, greater than 0. For the graph to remain above the x-axis, for y to be positive, greater than 0, x must be between what? -1 and 3. So can I show you to write the answer in the exam? X must be greater than -1, but less than 3. That's how you write the answer in the exam. Yeah. You might say, Mr. Morgan, why do you write it like that? Because guess why? Because between -1 and 3, the graph continues. See there, it goes right. It doesn't break. It doesn't keep going on. So once x is between this range of numbers, or these range of numbers, the graph will remain what? Above the x-axis. If x is less than -1, it gone that way. If x is greater than 3, it gone that way. That's where f of x is what? Less than 0. So for the graph to be less than 0, x has to be greater than 3, or what? Less than what? -1. But for the graph to be positive, x has to be between what? -1 and 3. If you draw a number line in the exam, number line can be the answers when the exam show the number line like that. Put 2 circles above it. And this would still be an answer. So once x is between those two numbers, then the graph is going to be what? Positive. Now, how do you read this inequality? I'm not going to leave it alone now without explaining to you to read it. Guys, I use two so-called less than sign. Let me tell you how I read it now. I read from the middle. I say x is, now even though you have a so-called less than sign, use the word greater than. Because the arrow points to the smaller number. Where the arrow points, Now, because we have a so-called less than sign, I use the word greater than. The arrow points to the smaller number, so I say x is greater than minus 1. So come again, forget about the 3 now. Look about this part. Look at this part here. Minus 1, come now, pay attention. Even I use a so-called less than sign, the arrow always points to the smaller number. Minus 1 less than x, or you could say x is what? Greater than minus 1. Yes, but, you could say but, or I could use the word and at the same time. It must be less than 3. See there? The arrow points to x, the arrow points to x, so x is what? Less than 3. So normally if I use two so-called less than sign, I read from the middle to the left, to the right. I say x, which is in the middle, must be greater than minus 1, but less than 3. School is over. So that will be your answer. Any question about that one? So the answer will be, yeah, the answer will be x is, that will be the answer. X is greater than minus 1, but less than 3. If they ask, guys, let me just use one stone and kill two birds. If the examiner asks instead, then the range of values of x for its function is what? Greater than 0? No, less than 0. I mean, if they had used this now, if they had said f of x, guys, in the exam, if I use this instead, if they ask for less than 0 instead, they'd have chosen the part that appears below the x-axis. So x would have to be less than minus 1, or you're going to break us two different things now. You're going to break us two different inequalities. X must be greater than 3. You don't, janitors do one inequality. You break it because the graph actually breaks. You know, see it there? The graph tells a story. The part of the graph appears below the x-axis. X has to be what? X has to go to that direction, less than minus 1, but at the same time greater than 3. And you break inequality as two different inequality. You don't write as one like this one. The reason why I write this as one inequality, because the graph did not break. The graph continues like this. See, the graph didn't break. See it here? The graph continued. It didn't break at all. It was one continuous graph. But the last part now, if it was less than 0, the graph appears two different times. The graph appears two different sides. So you also break inequality. Say, right, x is less than minus 1, or x is, use not and, you say or. X is what? Greater than 3. If you're asked about less than 0, okay? If you're asked about equal to 0 now, I said, let me use one so not the 3 birds. If you ask, no, they wouldn't ask about range. They wouldn't ask about range, no, range. They wouldn't ask about range. If they find a value where x is equal to 0, they wouldn't say range of value. They would say find the values of x for it to be equal to 0. Values of x, not range. What would be the answer? X would be what? Equal to those two numbers now, which is what? Minus 1. Or x would be equal to 3. Okay, note for me, guys. So I'm trying to use different ways the examiner could have asked you from the one question. So equal to 0, you read off those two numbers with the graph, cut x-axis. Because y equal to 0 is where the graph cut the x-axis. Same as what? F of x equal to 0. So because on the x-axis, y is 0, or f of x is 0. And those two numbers are where the graph cut the x-axis. It cut at minus 1 and what? And what? And what? And 3. Okay? I hope you guys know to factorize it. You could actually factorize this and get the same answer. I hope you knew that. You could have factorized this and get the same answer. Yeah, to it cut the x-axis, okay? You could have factorized it. All right? You guys can factorize it? You guys can factorize this expression? You can, guys, you know to factor. What will be the factors of this expression? Who can tell me? What are the factors? 2 factors. What are they? 3, 1. You guys, right, guys? X. Yes. Minus x. No, this is, no, what is it? No, put x right here. Let me put x here first. I'm not going to teach factorization now because we don't have the time. I want to show how to factorize this expression. And you're gonna get the same two numbers again. So what would be right here? This would be x again to get back a minus x. So which one would have to put plus? Is it this one is a plus or this one is a minus? Which one is this? Is it like that? You will get that. Is that the answer? If I expand this, do I get back this expression? If I expand that? Come, Genesis, walk with me, talk to me, Genesis, come. Is that correct, ladies and gentlemen? Do you guys can factorize the expression, quadratic expression, they can factorize? Or maybe you guys just don't want to talk. Okay, guys, anyway, go back over factorization. So those two numbers.
Mr. Morgan, some are saying they don't know based on the chat.
Oh. All right, let me ask you, but it's gonna be that in your exam, that is always there, your number one like part, number one part, maybe part D or part C. That's a factorization question normally. What about x squared then, guys? Anybody know to factorize this expression? What do you call it? What do you call that expression? Still quadratic, but you only have two terms. What's that? What do you call that expression? A difference of two? A difference of two?
2 square.
Excellent. What's the factorized form? What will be the factorized form of this?
It will be x plus 2. And then
so is
minus.
so the general form is a squared minus b squared. That's the general form. You take that general form. It's called a difference of two squares. Difference because you have a minus sign. That's why I get difference. Two squares because the two is above both numbers, so it's the two squares. It's called a difference of two squares. That's always the factorized form. A plus b, or you could have a minus b first, whichever one. So in this form, it has two terms again, look like this similarly. So we can express 4 as 2 square. Agree? The x is already squared, that's good to go. Come Genesis, pay attention, walk with me. So we put in the same form as what? A squared minus b squared. And if an expression take that form, what will be factorized form? The a is at the x, and the 2 is at the b. So it will be x plus 2, like I said it a while ago, times x minus 2. Okay? And if you expand, you get back where you're coming from. You get back the same x squared minus 4, okay? And I'm not really teaching factorization now, but you know, and if I have now this now, ax squared now plus bx plus c, which is our case now, you know, to factorize that, you must have two factors. Sometimes it cannot be factorized, by the way. But if it can, you must have two factors because the I square is 2. The I square is 2 must have two factors. Oh my Lord! I wonder if what time is it now? Guys, I don't know. It's you need to know to factorize, guys. Could you go to your teacher then, guys, and remind your teachers to remind you to factorize, please, for me? Whoever doesn't know, because it's a kind of. All right, let me see if I can finish and I go back to factorization. If I can do it for you before I leave, okay? Fair enough, guys. Fair enough.
Yes, sir.
Yeah, we can revisit factor. Let's say we can do everything first that I plan to do tonight, and then if at the time I go back over factorization because it's going to come on. It's always coming. It's a standard question for CSEC maths. That's always like your number one, like part D, or you know, it's a yet. You have to know to factorize, guys. There's no go around factorization. You have to know to factorize. Okay. All right, let's go down to the real thing now, guys. I'm trying to erase this as much as possible. Not going to waste too much time. I hope it's not distracting the others writing. All right, here comes now functions and relations. This part now is called what? Composite functions and so on. We have two functions, namely f of x and g of x, okay? The function f of x is defined to be 2x minus 1 divided by 3. And gx is defined to be 5 minus x squared, okay? Now, we're supposed to determine the value of, in part A, of 2. But what did I have there? Is it G or F? Guys, you must not only look. I always tell my students at university, you must not only look, you must see. You must not only look, you must see. Did they have G or F here? What do you have? F or G? Tell me.
G.
So in the exam, don't make any mistake. You can't afford to make mistake. You don't have time to make mistake. You must not only look, you must see. This is a G function. So you go to the G function and replace what? X by 2. you're actually using substitution. So anyway, say x in g, you replace it by 2. So it's 5. Come now, walk with me. Minus, what is x? 2. What else you must do when you substitute? You always put a bracket. Put a bracket. Put a bracket. Don't forget the bracket. Once you substitute in, put a bracket. It's always good. So 5, is it minus 4 or plus 4?
Minus 4.
Excellent. I told you earlier it has to be minus 4. Very good, not plus 4. The answer is going to be what? What's the answer?
1.
1. 1. School is over. School is over. Very good. Excellent. Very good. Okay, cool. All right, part B now. What is part B asking to find? Who can tell me?
The inverse.
Very good. So did I ask for f of 3? No. F of 3 would be, go to the f function and replace x by 3. So guys, you have to be observant in the exam. You don't have time to make mistake because you're going to have to start all over. No, you don't have time for mistake. You must be observant. They didn't ask for f of 3. That's f inverse. The minus upstairs as an exponent or a power means what? Inverse. It means inverse. Yes. It doesn't mean 1 over. It doesn't mean 1 over. No. A to the minus 1 is the same as what? 1 over a to the 1. A to the minus 2, that's what? That's indices. Indices is 1 over a to the n. So now with respect to a function, f to the minus 1 like this doesn't mean that is 1 over f. It doesn't mean 1 over f. It doesn't mean that. No. Note for me somewhere. Note for me. It doesn't mean 1 over f. No. It means inverse. It doesn't mean reciprocal. It doesn't mean reciprocal. Okay, so we're going to find the inverse of what? Of f first. Now, I'm going to find the inverse function. We're going to replace what? 3 inside the inverse function. Are we going to put 3 right here, guys? Are we going to put 3 right here in the original function? That's what examiner want. Let's put 3 where x is in the original function.
Yes.
I'm asking a question now. Does the examiner want us to find? Does he want us to find f of 3? Is it that the examiner wanted to find f of 3?
No.
No, we must not find f of 3. No. I just want to make sure it's clear, okay? Okay, we're going to find the inverse of the function and then replace 3 in that inverse function. Now, to find the inverse of a function, there are how many steps? Who can remind me? How many steps are there in finding the inverse of a function?
Sir, about 5.
How you get 5? You came up with, you should be sitting next to Einstein. You should be sitting next to Einstein.
Think about 3, sir.
You should be sitting next to Albert Einstein or Isaac Newton. You invented two different methods, 2 different ways, 2 different steps. That means if
4.
or is it 3? Is it 3? I think
There are 4.
if my memory serves me right, it's 3. If my memory serves me right, it's 3 ways, 3 steps. Okay. But thanks for trying. So if you did 4 or 5, I want to see what those 4 or 5 steps are. You should be sitting next to Einstein. And I'm not joking. I'm serious. I want to know what those 4 or 5 steps are. So I'm going to tell you my 3 steps first. And I'm going to tell me your 4 or 5 steps. Okay, let me tell you my 3 steps. Note for me, guys, to find the inverse of every function under the sun. There's a sum or all. Every function. Every. Oh, by the way, not every function of an inverse, by the way. Not every function of an inverse. But I'm not on a stray. I'm not on a stray right now. But not every function has an inverse, okay? So not all function has an inverse. But if the inverse exists, listen carefully, if the inverse exists, there are 3 steps to find the inverse of every function under the sun. The first step. Right for me, please. The first step. Step 1. You replace or say let y equal to the original function f of which function is it? Is it f? Oh yeah, f, right, f. Let y equal to f of x. And whatever the function is called, if you call it g, whatever, but in this case, is the f function, must find the inverse of. If it was h, then y equal to h of x. If it was g, y equal to g of x. So whatever the function is called, okay, you make y equal to that first. That's step 1. Cool. Step 2. Having done that, you must interchange variables. Interchange. That's the spell interchange, yeah? Variables. What does that mean? You replace x by y. Let me write what that means in case you don't know. It means you replace, or you swap. You replace x by y and y by x. Replace x by y and vice versa. Now, the student who listens the most learns the most. Ladies and gentlemen, there is no mystery in mathematics. The mystery is in your minds. There is no mystery in mathematics. The mystery is in your minds. Last step, you must now let y be the subject of the formula. Let me just say transpose for y then. The transpose for y. Transpose for y. That means that you must what? Let y, or make, let's say you write word make. You make y the subject of the formula. Make y the subject of the formula. And then school is over. You have found your inverse. All right. Take a picture for me, please, of those 3 steps. Wait, what happened a while ago? It disappear? Oh, what's going on? What are the 3 steps? You call y f of x. You introduce y and replace it by you replace f of x by y. Then you interchange variables. You replace x by y, y by x. And then make y the subject of the formula. And that's your 3 steps, okay? Guys, anybody have any more steps? 4 or 5 steps? Well, those are the 3 steps I know, okay? All right. Make note of me quick now, guys. All right. Let's go to a function. Our function is called what? F of x, okay? So why are we choosing f of x, guys? Because they ask us to find f inverse of what? Of 3. But before you can find f inverse of 3, you have to first find the inverse function of what? Of f. Cool, let's go now through the 3 steps now, guys. Ready now? Come, geniuses, now walk with me. So what are we going to do now? We're going to first let y equals to f of x. Because that was the function that you're asked to find the inverse of, the f function. Then, what does it mean? It means that y then is going to be replaced by f of x, or fx replaced by y rather. So we're going to call it 2x minus 1 divided by 3. So all I did a while ago, I replaced this by y. Everybody follow me? That's the first step. That's step 1. Everybody appreciate that so far? Any question? Are you guys, everybody hearing me?
Yes, I'm hearing. No question.
Excellent. Next step is what? To interchange variables. You're going to replace x by y or y by x. So you're going to say x now will be equal to 2y minus 1 divided by 3. What have I done? I interchange variables. Anywhere I say x, I call it y and vice versa. Last step is to what? Make y the subject of the formula. So you know, don't know, guys, now algebra. So you're gonna solve for y. You're gonna solve for y. Same as what? Making y the subject of the formula. What do you solve for y? What's the first thing you have to do? Can I multiply 2 by 3 or find the LCM? What do I need to do? Can I cross multiply to get rid of the fraction? Can I cross multiply, guys?
Yes, sir. You got to multiply.
Because x is really over 1 now. You know, so x is really over 1. Yeah, you can cross multiply. You could find the LCM. You could multiply 2 by 3. It doesn't matter what. Yes? Jaden, have a question? It doesn't matter. Okay, it doesn't matter what step you do, guys. The same concept. Once the correct step you're doing. If you multiply by 3, you find the LCM across multiply, get the same answer, okay? Because I told my student that math says that true science maths is stronger than Hobia. No matter which way, you get the same answer. If I find the LCM is 3, if I cross multiply, I get what? I get 3x equal to, guys, I cross multiply, so it's 3 times x, and it's y times what? I mean, 1 times what? That expression, which is the same as the same expression, it doesn't change. Same as if you find the LCM, you get the same answer. You get the same answer. You actually get rid of the fraction, okay? So whichever way you're comfortable doing it in your exam, do whichever way you're comfortable doing it, okay? Just don't make any mistake. All right, cool. Having done that now, oh, before I move on, everybody saw where this came from?
Sir.
Yeah.
Any question about it? I can move on now.
Yes, sir.
So we're
Sir.
trying to make, we're trying to make while let's look at the formula. So we first get rid of the fraction. Let's bring over the 1 now. We want to keep y on one side. Let's bring over the 1. We have 3x plus 1. Come, Genesis, walk with me. Pay attention. Equal to 2y. Question, yes, somebody raise their hand, yes?
Sir, so I was going to ask if you could have multiplied the 3 instead.
Multiply both sides by 3.
Yes, sir.
Yeah, man. Yeah, you can do it anyway. Yeah, man. Thank you. Yeah. We get the same answer. Because we can either cross multiply both sides by 3, or you can find it LCM and get the same answer. Any 3 ways to get the same answer. You're going to end up with a 3x equal to 2y minus 1. Okay? So trust me, math is a two sides. Math is very strong, powerful subject. All right. Okay, now, so I brought over the 1. Last step, I divide both sides by 2, right? Because y must stand alone. I'm multiplying 2 by y. So I do the opposite sign, which is division. So I divide both sides by 2. So I get 3x plus 1 divided by 2 equals to y. And we finish. But can I talk to you? You see this y here? You see this y here, guys? This y here is not the same y that we started out with. These y's are different. These are different, my friend. They are different. Not the same y. No. They are different. Let me write it. These are different y's. These y's are different. Not because you're seeing y. No, they are different. In fact, this y that we just found, this last y here, it undergo a transformation. Who get him what is this y? What is it called? Who can tell me? Anybody tell me? I think you're gonna get a 1 for maths or a 2 for maths or whatever. I predict you're gonna get a 1 or a 2 for maths. If you tell me what this y is, what is this y? This new y. What is this new y? The new y called? It's not the same y as before that we started out with. What's that y called, ladies and gentlemen? Yes, who can answer me quick? Guys, be confident now. Be confident. What is that y called? That we just found. The last y is called what? It's the yeah. Mullins, Curry, yeah, it's the
inverse.
Excellent. Thumbs up. You're gonna get a 1 for maths or a 2 for maths. It's an inverse, my friend. Yeah, man. True. Big man thing. I would say to my student, big man thing. This is an inverse. We just found, yes. So you tell the examiner that 3x then plus 1 divided by 2 is equal to f inverse. That's it. School is over. That's my inverse function. Yes. It undergo a transformation. I don't know if you know what inverse really is, Inverse is, if you look at in terms of a graph, so geometrically speaking, the inverse of a function is simply a reflection in a line y equal to x. Yeah, that's what it really is. It's a reflection in a line y equal to x. Yes, that's what it really is. It's a reflection. It undergo a transformation. So it's 2 different y's. So the one I just found is called the inverse. And that's the answer. That's the inverse function. Okay? Any question about that one? All right. Then now we're going to replace now x by 3. Because we have found the inverse function. Now replace 3 now inside there now. Okay, come Genesis, walk with me. So we're going to say now f inverse of 3. Do what you're asked to find. Equal to 3 times 3, because 3x plus 1 divided by 2, that's what inverse function. Replace x by what? By 3 in our function, plus 1 all over what? Over 2. All right. So 3 times 3 is 9. 9 plus 1 is 10. So we get 10 over 2, which equal to 5. So the answer is 5. Okay? Any question? So the answer is 5. So f inverse of 1 equal to, f inverse of 3 equal to 5. That's the answer. Everybody saw I get the 5? All right, please transcribe, take a picture, do whatever you need to do. All right. That was that question. Take a picture. I need to move on quick now. What time is it now? I need to move on. All right. So, okay. So that was part A. Okay. Okay. No, part B, right. All right. Let's move on now fast now, guys. So I'm going to erase the script now. Like I said. All right. I don't think this affect me changing the slide. I don't think it's going to affect the next part of it right coming up, right? Sometimes I look at the writing is still existing in the same. The writing sometimes appear on this next slide. But this one, what I love about this, I don't know if it's Mrs. Johnson did it like that, but it is flowing the way that's different from the normal one. And I use that you sometimes if I write on the page.
Great.
Oh, Mrs. Johnson, thank you very much. I love this. I don't know if it's you did this way because when I write on this slide that Yui or whatever I'm presenting, I have to erase it because even I change a page, when I change a page, the writing is still showing on the next page. And so if I write on page 1 and I go to page 2, the writing is still there. It's not moving. So I don't know if it literally is they created that thing that the writing is still there. Even if you go to page 10, the writing is still there.
Still there, yes.
That's why I still keep erasing. But I realized that
it won't affect the others. It won't
that's
affect
good.
the others.
That's good. So I didn't have to erase it then. I don't want it to erase in the future then. Yeah, thank you very much. All right, now. So part 2 is the final. Guys, this is called now the composite function. Note for me, guys. It's called function composition. You have to know when you're doing your exam topics, guys, know what part of the syllabus you're under. You just always know. The student who normally does well is the student who's aware of what topic you're under. Where is it? Where is this up here? It's called function composition. So I want to explain to you what this means now, guys. Now we can write it 2 different ways, okay? So what the CSEC normally does, sometimes I realize when I look at the paper every year, sometimes I see it different. Sometimes CSEC have this like this. It means the same thing, okay? It means the same thing. Like that. Let's write it like that. They write it like this. G of x like that. Right, that's what it means. CSEC does that sometime. In the past, they used to have this circle mean like that. I don't see this anymore. This is an exam paper. I don't know if it came off the syllabus. I need to look and see if it's on the syllabus anymore. I don't see this notation anymore. And if it was confusing and they took off the syllabus. And even for Cape maths, I don't know if I use this anymore. But this is saying it means f of g of x. That's what it really means. Yes. f of g of x. F of g of x. It does not mean f times g. It doesn't mean that. No. It does not mean f times g. So note for me, guys. Note for me. F of g of x, as it's written right here, is not equal to f of x. It doesn't mean f of x multiplied by g of x. It doesn't mean that. No, it doesn't mean that. So sometimes students confuse the issue and they multiply the 2 functions. No, that's what 6 that is not what 6 asks you to do. You must not multiply the two functions together. It doesn't mean multiplication. No, it doesn't mean that. It means composition. It means you must replace one function in the other function. You must replace it inside the other one. Replace it, okay? You replace one in the other. Because if you had f of 2, for instance, I replace 2 in the function f. So f of g of x means that you go to the function f. I think I prefer this notation, and I think I prefer this notation, not than this one. I don't like this notation at all. Yeah, it's like a little confusing. I think CSEC should use it like this. This one, yes. It more shows like you're replacing one in the other. Yes. But let me show you the trick now, guys. The trick how to know the difference between multiplication as opposed to composition. Let me show you the fundamental difference now. for it to mean multiplication, you have to write x twice. Note for me, guys. Note for me. This here means multiplication. You write x twice. It means multiplication. You write x twice. See it here? It means multiplication. It's just notation. It's really notation. It means multiplication, okay? So when I write x twice, f of x, g of x. When I write x twice, it means multiplication. It means f times g. When I write x once, it means composition. It means composition. It means you go to the outer function. This is the outer function, the outer one. The one to the left then is the outer one. So you go to this function here, the one to the left. I call it the outer function, the outer. That's what I'm going to call it. You go to the one to the left, the outer function. And you replace now your g of x in that function. So this one is the one you're going to replace. This is called the inner function. Or the one to the right is called the inner function, the inner one. The inner function, okay? So you always go to the function on the left. That is called the receive. So f is called the receiving function. It actually receives. And g is a given function. The one to the left is the receiving function. And the one to the right is the what? The given function. So you actually pass the function to the right. You pass it to the one to the left. Like you're running a relay. So the one to the F receives the one to the right. Let's go now. Keep it simple now. Keep it simple. We go to the function f. And in the function f, replace what? X by g of x. That's all it is saying, guys. Come again. You go to the function f. If you had f of 2, you go to the function f, you replace x by 2. So f of g of x means that you go to the function f, and in your f function, you replace x by g of x. If it were g of, on the other hand, if it were this instead, if that was your question, ladies and gentlemen, you'd have gone to your g function, and in your g function, you replace x by f of x. But our question didn't ask about that. Okay, let's do the question now then. So we go to our f function, ladies and gentlemen. You go to the f function, and in your f function, you replace what? X by g of x. Okay. Come, Genesis, now walk with me. The student who listens the most learns the most. All right. So what do I therefore do, ladies and gentlemen? So I go to my function then. Having said that, then watch careful now. Watch carefully. Pay attention now. Look. All right. So let's write what they have here now. So f, let's write with this but color instead. F of g of x means that you go to your f function. Let me write what f was again. What was the f function? Your f function was given as, what was it again? It was 2 times x minus 1 divided by 3. That was your f function. Yes, come Genesis, walk with me. And your g function was given by, don't forget what it was. It was equal to what? It was 5 minus x squared. Okay. You go to your outer function, your f function, and in this function, replace x by g. If it were 2, you replace x by 2. So the mere fact that you're going to replace x by g of x, you must write 2 times x. But what is x? G of x. Come, Genesis now. The student who listens the most learns the most. Come, guys, pay attention now. You replace x by g of x. So anywhere say x, replace it by g of x. So minus 1 divided by 3. Okay. Now, having done that, my friend, now bring it to this conclusion now. You do what it says now. All right. Come now, guys. Please now. Stay with me, pay attention. So let's do the actual thing now itself now. So you go now to the function now. So in your function now, f, you're going to have now 2 times. But what is x? What is g of x? 2 times, what is g of x? 5. What have I done? I go to my f function, and anywhere say x in my f function, I replace it by g of x. Okay, and that's it. And you do the thing. Are you done? Do the thing. Do whatever you need to do. The algebra. So I can now remove the bracket now. I multiply 2 by what? 5, I get 10. 2 by minus x, I get minus 2x squared. I mean, x squared, I get 2x squared, I mean. Minus 1 all over 3. Combine like terms. So we have 10, if we have 10 and a minus 1, we get what? 9. So we get 9 minus 2x squared. All divided by 3. And that's your answer. So you simplify, you can't go any further. You can't go any further. That's it. You cannot go any further. So that's your simplified, okay? Because it's in its simplest form. So the answer is 9 minus 2x squared all over 3. Any question about that one, guys? All right.
So you basically,
Yes.
you basically plug in
You plug in. You plug in.
Fx and the Gx, right?
You plug in. Yes, it is with the plug in.
All
Use
right.
the word plug in very good. You plug in the f function, the g function.
Okay.
You treat g of x as a number. Very good. Use it red. I love what you said. You plug it in. So you're going to treat g of x as a number. So in your f function, anywhere you say x, you replace it by g of x. You plug in g of x wherever you say x. Just like you're plugging a number. Very good. And that's it. I like that expression, plug it in. Yeah. It is that they can actually relate to that more. All right, cool. Any question about that one, guys? Okay. Take a picture for me quick. We need to move on now quick. All right. Some questions last longer than some, I realize. All right, what is this asking now? Oh, okay. Okay, sketch a graph of g of x. Oh, okay, no problem. Now, guys, if the examiner uses the word sketch as opposed to plot, it means two different things, okay? Note for me. Plot is the same as draw. They use these two words interchangeably. They might say plot or draw. No, that means that it has to be accurate. Can I show what plot and draw were? That was what we did a while ago. See here? That was plot. This is plot. See here? That is plot or draw. Yes. Because they gave us a table of values. It has to be accurate. See there? See there? That was plot or draw. Yes, it's a draw the graph. Now, if CSEC use the word sketch, no, sketch doesn't have to be accurate now. What sketch means, guys, sketch means that you just need to know two things. Know where the graph got the axes and know the graph shape, okay? Yes, that's all you have to do for sketch. Come again, guys, for sketch, you need to know two things for sketch. Show the examiner where the graph got the axes and know the graph shape, okay? So let me write my G function now that we're gonna sketch. So guys, don't forget now your G function was given by what? It was what? 5 minus x squared, okay? All right. So the key thing you need to know, guys, to sketch a graph are the two key factors. Know where the graph got the axes, that's one thing, and know the graph shape. That's where you sketch a graph. Now, how do you know where the graph got the axes? So we have two axes. What are the two axes? The x-axis and the y-axis. So I just call it one thing. Know where the graph got the axes. Now, where does the graph got the x-axis? The graph got the x-axis where y is 0. Where does the graph got the x-axis? The graph got the x where y is 0. Where does the graph cut the y-axis? The graph cut the y where x is 0. So you have to just know that. Just know that there's no going around. So guys, record what I just said. The graph cut the x-axis where y is 0, or when y is 0. Vice versa, the graph cut the x-axis, that's when y is 0, and vice versa, the graph cut the y-axis when x is 0. Come again, the graph cut the x when y is 0, or where y is 0, and the graph cut the y where x is 0. So if I want to know then, in other words, if I want to know where the graph cut the y-axis, I make x equal to 0. That's all I'm saying. Come again. If I want to know where the graph cut the y, I make x equal to 0. So when x equal to 0, I want to find where the graph cut the y-axis, okay? So I call the function g, but we always call it y for convenience, same as g of x or f of x, we call it y. So when x is 0, we want to know where the graph cut the y. You replace it by what? By what 0, so it's y equal to 5 minus what? 0 square, because x is 0. So we normally use these two convenient points. The points are x is 0 and y is 0 to know where the graph cut the axes. So when the x is 0, the graph cut the y-axis. When y is 0, the graph cut the x-axis. So that vice versa. So the graph cut the what? The y at 5. So let's put on our numbers now. It's 1, 2, 3, 4. If I use 1 centimeter to represent 1 unit, like a scale of 1 centimeter for 1 unit, this is like 0. So the graph passes through what? When x is 0, it passes through 5. Okay. Now, where does the graph cut x-axis now? The graph cut the x when y is 0. So when y is 0, the graph should cut the x-axis. By the way, and other way it cut the x-axis, and other way it cut the x-axis. But if it cuts the x-axis, that's where y is 0. You go to the function, replace y by 0. So we have 0 equal to 5 minus x squared. So you're gonna now solve this equation. How do you solve this equation, guys? We can bring over the x squared and make it positive. We can have x squared then. Bring it over, make it positive. X squared equal to 5. How do I find x? Who can tell me how I find x? What can I do to find x? Square root, both sides. Right? The square both sides, right?
Yes,
X
sir.
Because
Yeah.
the I is 2, you must have 2 solutions. So x equal to plus or minus. Don't forget this, guys. Whenever you square, you have plus or minus, the root of 5. Yeah. Don't say x equal to root 5. You're going to lose mark. If you leave it off, they leave off a grade. They will leave off a grade. If you leave it off, they leave off a grade. Simple as that. It's plus or minus. Because the I power is 2, you must have 2 solutions. The I power tells us how many solutions you're supposed to have. Because the I power is 2, you must have 2 solutions. So you have plus or minus. That's about 2 point something. You don't need, I don't care what root 5 is. I don't really care. This root 5 is about 2 point something. This is 1. This is 2. Root 5 might be somewhere here, I think. 2 point something. So this is minus 1. This is minus 2. This might be about 2 point something. So the graph passes through what? Minus root 5 and root 5 on the x-axis. No, so we know, so what I say, know only 2 things. Know where the graph got the axes and know the graph shape. Now, the shape of a graph is based on the I power. Let me teach you now mathematics. Come, Junior says now, walk with me. The shape of a graph is based on the I power. What does that mean? If the I power is 2, the graph going to bend 1 time. If the I power is 3, the graph bend 2 times. So normally, not all the time, but normally, the number of times that the graph bend will be 1 less. It's going to be 1 less than the I power. So the I power is 2, it has 1 bend. The I power is 3, it has 2 bends. Not all the time it happens though. So if you move on to further maths, like if you do like A-level maths, K maths, you're going to learn some more stuff. But not all the while that is true, but because there are some things that are, that are there. But anyway, but normally if the I power is 2, the graph will bend 1 time. If the I power is 3, the graph bend 2 times. So the number of times the graph bend is normally, sometimes, 1 less than the I power. So because our I power is 2, we're going to have 1 bend. It can bend this way or this way. But obviously, guys, you know which way the graph bend because you just have your points a while ago to plot. So is the graph going to look like this, guys, as a cup? Or will it be like a mountain? What will your graph look like?
A mountain.
Because we're going to plot the points. Sit here, school is over. Wicked. Ladies and gentlemen, is it maths beautiful? Is it maths beautiful? That's a graph. I always say maths is a true science, my friend. Maths is stronger than Wobia. All right, so this is my graph. So it's a negative x squared graph. So the graph is going to bend like a cup. I mean a cap. If it was a plus x squared graph, the graph bend like a cup. So that's our graph, okay? And you have to sketch a graph. Any question? All right, take a picture quick for me. That was that question. All right, let's move on now, guys. Move on now. All right. Here comes now the real McCoy. The real McCoy, the real deal. This is the real deal. Okay, so here now, so CSEC gave us a graph. That's a sketch already for us. It's on the grid above, which is the graph itself. The grid is called the graph paper. That is that graph paper that I have there. Draw the tangent. Okay, what's a tangent, by the way? A tangent. Who can tell me what is a tangent?
A straight line.
That does what? That does what?
That cuts through one point of a circle or so.
Cut or touch?
Touch one point.
Well, very good. Well said. Excellent. Very good. A tangent is a line or a straight line. You want to say straight line that touches a curve, or it can be a curve, of course. Come again. It's a line that touches a curve at only one distinct point. Come again. It don't cut in, it touches, not cut, it touches. Yeah, well, it's called a secant. A secant cuts. A secant cuts, okay? Cuts. But a tangent touches. Let's say touch it right here, okay? So it's different from a secant, okay? Cool. Okay, anyway, I don't want to stray. So it's a line that touches a curve at only one distinct point. Cool. Okay, now, so we're going to, at the point x equal to, at the value x equal to 1, we're going to draw a straight line. You have to be careful now, guys. Let's draw that line now. All right, guess what I'm going to do now, guys? Before I draw my line, I'm going to look at what the question asks below. Because you have to look at what they're going to ask, So you have to, before you draw a line. Let me see what it says, use the tangent to estimate the gradient. Okay. Let me see what they ask again in the next part. Okay, write down the equation. All right. The reason I'm looking what they're asking, I want to know how to draw how long must I draw my line, or how long must I draw my tangent. Should I draw it short or long? The mere fact that they ask more questions about the tangent, I'll draw it very, very long. The longer it is the more information I get. The longer it is, guys, don't draw it short. Make it long as possible. The reason why I wanted to make it long, I want to draw a line that cuts the y-axis, okay? The mere fact that they ask about the equation of the tangent, that you must find at the end of the day, I'm going to draw a line that cuts the y-axis. I'm going to go all the way through with it. Not going to do it short. Let's see now what we do with thing now, guys. Now concentrate now. Now pay attention. Let's see where x equal to 1 is now. This is where x equal to 1 is. Right here, so. See it here, guys? See it? Everybody see it? Right? Is that x equal to 1? Right there, guys? Come to Genesis, tell me Genesis. Genesis, talk to me, Genesis. Come, though, guys. That's x equal to 1 right there. Yes or no?
Yes.
No,
Sir.
yes, excellent. You're going to use a ruler in the exam. Your ruler, don't do it freelance like me, no. Don't use it like me, because I don't have a ruler. Use a ruler in the exam. Line it up with the ruler properly. You want to get full marks. Use a ruler and draw. You put the ruler right. I can't really show you what I want to show you, because I can't show you. But what you have to do, guys, you put the ruler in a way where the line don't cut the curve. So pretend not to have a ruler. Pretend not to have a ruler now. Use it now. Pretend not to have a ruler. So my line must not cut like that. No, it must only touch at one point only. So let me see if I can show you what I want you to know, guys. I'm going to draw my line. Come, Genesis, pay attention now. Stay with me, walk with me. I'm going to draw my line like this. Let me change the color again. So let me use a different color. Let me try this color here. So I'm going to draw my line like this. I go straight down with it, guys. Straight down. Wicked. Oh no, I can't say wicked again. No, the line not straight. But you get the point. Guys.
Yes, sir.
What kind of like Mr. Morgan? Come, Mr. Morgan, man. You must kind of better than that, Mr. Morgan. You must kind of better than that, Mr. Morgan. What really I do? Oh my God. I must kind of better than that, guys. I know you guys kind of better than me. Anyway, use the ruler is a concept, guys. The really concept is important. The concept. So pretend that was a straight line. Pretend that was a nice, perfect straight line. I want to make sure you don't cut it at all. It only touch it at one point. All right. Now, that's my tangent. That's part 1. All right, okay, cool. Part 2 say now use the tangent. No, that's why I wanted to make sure my line is drawn in full to estimate the gradient. The gradient of the tangent. Guys, what is the gradient of a line? Of a straight line? If I have 2 points. So call it x1 and x, and I know that's what you're told by a teacher. x1, y1, x2, y2, the x and y value. What's the gradient of that line?
Yes.
What's the gradient of that line? The difference in the y's, right? Anybody remember from your teacher told you? What's the gradient of a line? The gradient equal to? What does gradient means? What does gradient means? It means what? Slope. It tells how the line actually slopes, right? Slope. So they use these two words interchangeably. It tells how the line actually slopes, if it's steep or not steep, okay? So what is the formula for gradient of a line? That difference in the y's. So if you say y2 minus y1 divided by
x2 minus x1.
But can I tell the truth? Can I tell the truth? Nobody forget this. Nobody forget this. If I start with this y value, then I have to start with this x value. I can't say y2 minus y1 divided by x1 minus x2. No, that's not true. If I does that, then God help me, it's not my day. If I do that, God help me, it's not my day. This is not true. If I say y1 now minus y2, after now say x1. Yeah, man. Because if I start with this point, I have to start with this point right first. You can't start with x1 and then no. So the same y value start with, you must start with the same x value. So these must be the same. So these are the points, x2 and y2 go together as 1 point. So if I start with y2, I must start with x2. If I start with y1, I must start with x1. If I use y2 instead of, if I use x1 instead of x2, we're gonna get the correct number for the gradient, but we're gonna get the opposite sign. So if your gradient should be 5, you're gonna get minus 5. Or if your gradient should be minus 5, we're gonna get 5. So if you use a different x value by trying the other way, you get the same numerical value. So you get the same number for the gradient, you get the same number for the gradient, but a different sign. You get the opposite sign. So it is imperative, guys, that you remember that. So if I start with a certain number for my y value, I must start with the same number for my x value. Okay? So to find the gradient of a line, we just need 2 points, okay? That lies on a line, that it has to lie on a line. We can't use points off the line, it has to be on the line. What is our example now in this case now? Let's see. Our line passes through what? No, I have 2 points. I'm seeing 2 points. I don't know if you've seen it, guys. Yeah, man, I'm seeing 2 points here. Can I show what my 2 points are? Let me show what they are. I'm going to use this point here. X is 1. Y is 3. That's 1 point. 1, 3. And I'm going to use this point here, right here. So, yeah, man. Because the point must lie on the line. X is what? 0. Because on the y-axis. Y is what? Minus 2. Then school is over. School is over. The question done. Yes. So my gradient would be equal to guys, now which point you want to start up with? Which point you want to use first? Any point, it doesn't matter. Any point, you get the same answer. You want to start with 3? So it's 3 minus 2. Don't forget the minus sign. It's minus 2, not plus 2. And I mean not 2. Because is x is y2 minus y1. So it is 3 minus. So if I call this y2 and y2 and x2 and y1 and x1. So it is 3, which is your y2. Subtract y1, but in this case, your y1 is minus. So it's 3 minus minus. Okay. And because start this y value, I will start with the same x value. 1, so it's 1 minus 0. So the answer is 3, but 3 minus minus is a plus over 1. So the answer is 5. And gradient is 5. Okay? Everybody appreciate what I've done? Good to go?
Yes, sir. Good to go.
No, why is, okay, who can tell me quick now? What time is it? Who can tell me why the gradient is at minus 5? Why didn't get minus 5 for the answer? If it were minus 5, almost my line slope for me to get minus 5, or a minus number. My line must be in what direction? This direction? Of course, yeah, man. Let me answer for you. If a line is like this, the gradient is negative. If a line is like this, the gradient is positive. Yeah, man. If a line is horizontal, the gradient is 0. It has no gradient. There's no slope. The gradient is 0. So every horizontal line has a 0 gradient. Every line in this direction has a positive gradient. This is what? Negative gradient, okay? All right? I know some of you might know already, or some people might not remember. And the last part of the question I'll say, write down the equation of the tangent in this form, okay? Guys, but guess what? I already know what the gradient is. In this equation, y equal to mx plus c. What is m? M is the real McCoy, the real big man. M is the gradient of the line, the gradient. That's what M represents in the equation, the gradient of the line. The M is the gradient that we just found a while ago. What is C? C is what? The intercept on the y-axis in this case. The vertical intercept. In this case, my y-axis is my vertical intercept. In my vertical line, I mean. So C is the intercept on the y-axis. The vertical intercept. And all the while you call the y-axis the vertical line y, so I have to say vertical intercept generally. Okay, because we can call the vertical line v sometime v. But C is where the graph cut the vertical axis. In this case, my y-axis. So if this is my y-axis, and this is my line, this is my C. If this is my y-axis, this is my line, this is my C. This is my axis. This is my line. This is my C. Everybody see what C is? Everybody see what C is? Any question? So C is where the graph cut the vertical axis. Okay. So because I know M is what? 5. So Y then would be equal to 5 times X. So the only thing you replace is M and C. You don't worry about Y and X. Y and X are the variables that must be there. Y is a dependent variable. X is an independent variable. M and C must be found. But we know from our part 2, what we just already established that the gradient was 5. So M is 5. What is C? What was C again in my line? It cut the Y at what? Minus 2? C is minus 2. So school is over. So the answer is what? Is Y equal to 5x minus 2. And that is your equation of what? Of your tangent. And that's the answer. Okay. Any question, guys? All right. We have to move on now, guys. Time is kind of coming against us. Let's hurry up quick now before I want to do everything that I plan to do tonight. So let a graph tonight, man. Whoa, let a graph. Okay, the following diagram shows the graph of x squared plus x. Again, it's again a quadratic equation or expression. Okay, it says now, find the roots of the function. Okay. Guys, what does roots of equation mean? What does roots mean? What do we call the roots of a function or equation?
X.
Elaborate for me. Is where the graph cut
X intercept.
Excellent. Very good, Macho. The roots are called the solutions. Yeah, or the roots. Some people call it the zeros. If we do add maths, they're going to call it add maths zeros and add maths. Sorry, if we do Cape maths. The zeros are called it the roots, okay? So we use these words interchangeably. So get familiar with the words that CSEC use. You have to look at the syllabus, that's what the syllabus says. If you use zeros or use roots or whatever CSEC said, the syllabus say, okay? Guys, try to get that syllabus, guys. I know you can YouTube the syllabus or Google the syllabus. Yeah, get the CSEC syllabus, guys. To make sure you're on track with your teacher to know what the teacher. Don't depend on your teacher to do everything for you. Because you're responsible for your work as well. Not the teacher alone must do everything for you. So see if you can get that YouTube things and use the internet and whatever you use, guys, for your personal gratification or your personal whatever you're having fun on the screen time. Guys, use it for something productive. YouTube or Google your the syllabus for CSEC, the current one, whatever the current one is. I don't know if it's 2022 is the current one. I don't know whatever it is. But look at the one that is the current one and look at the syllabus and say what students supposed to know. because you're supposed to cover certain things by a certain time to make sure you cover the entire syllabus, okay? All right. So we go to the graph. So the roots is where the graph called the x-axis. What are the numbers? What are the numbers? X equal to what are the two numbers? It cut it at what? At minus what? 2 and 1, right? So the answer is x equal to minus 2, or you say r, x equal to 1. And by the way, guys, if you factorize, you get the same answer. If you factorize, you get the same answer, by the way. Yeah, man, you get the same answer. You get x. I don't know if I have time to teach you factorization tonight, because time is really against us. I say factorize this expression. Yes, I factorize it, okay? And if you make it equal to 0, you get the two values I get a while ago. You get the same two values, okay? If you make it equal to 0. That's where y0 with the graph called x-axis. That's where y0 with the graph called x-axis. You get x plus 2 equal to 0. That's the sub the equation. And then r, x equal to 0. And then x equal to what? Minus 2 or 1. That's where you get the same answer. They get the same solution of the roots, okay? All right, I guess I don't have time to teach it right now, but yeah. So that's the first part. Okay, we must now find the coordinates of the y-intercept of the function. So they want where the graph cut the y-axis, but they want it at a point, at x and y value. Where is the graph cut the y-axis? At what? At minus 2? What are the coordinates, guys? What is it? At minus 2 for y, what is x? Is it 0?
Yes, sir.
Excellent, very good. Back because on the y-axis, x is 0. Excellent. The minimum value of the function, minimum value, guys. What's the minimum value? Can you see the minimum value? It's right here. Oh, where is it again? Where's the question? Oh, the function is right there. Where's the minimum value? Can I show what it is, where it is? I'm gonna draw this line right here. So it's somewhere right here. The lowest point. That's about minus 2 point something, though. Whatever this number is, minus 2 point something is minimum value. Well, what I did, guys, I actually did it by completing the square. You don't have to know. I don't know if you know to complete the square. That's a part it's on the syllabus, by the way. I complete the square to confirm the minimum value, and I got minus 2.25. Well, but CSEC normally give a mark, you know, they have a plus or minus. I think 0.5. They have a range. So if you get between a certain point, they get full marks, I think. Yes, that's what they do for CAPE. That's what they do for CAPE. So if your answer is within a certain range, you get full marks if you're in that range, because you're doing an estimation and you don't really do it accurately, because you can't see those grid. You can't read off those small numbers in on your grid. They give you a range of values that you must get for the final answer to get full marks. So once you're within those decimal, you get the full marks for the question. That's what CSEC number mark. That's what CAPE mark, by the way. That's what CAPE mark. Okay. All right. Anyway, so we got minus 2 point something. So I know it's because I did it by completing the square. I got minus 2.25, the minimum value. That's the lowest point on the curve. That's the lowest point as the minimum value. All right. Next one now, we're going to find now the equation of the axis of symmetry. The formula for that is x equal to minus b over 2a. Yeah, anybody knew that? That's the equation of the axis of symmetry. Make note of that for me, guys. That's the find the axis of symmetry is minus b over 2a. But in your question, you need to know what is your a, what is your b. So your function was y. Let me remind you what it was. It was y equal to x squared plus x minus 2. That was your quadratic. Because this formula here came from the, not really formula. This equation came from the ax squared. That's where it came from. Plus bx plus c equal to 0. Yeah, come Gina says, no, walk with me. That's where it came from. They use this to get this. And by the way, I'm not sure enough to show where it came from, but yeah, right. And then now, what it is, it tells you now, if you have a graph like this, you want to divide the graph equally. That's what it's saying, equally. Like a symmetry, like a mirror. This part must be the same as this part, a mirror. So if I draw a line through that, it must be a mirror of each other, mirror. That's what it really does. It gives you what line must divide the graph into two equal parts, okay? Like a symmetry, okay, it must be symmetrical. And that will give us the formula for that. So what you need to know what is your B in your equation. Your B is what? Your B is what? The number that comes in front of the X. That's your B. Your B in this case is 1. B is 1 in this question. Your A is what is in front of the X square. In this case, our A is 1 as well. So once you don't say the number, guys, it is 1. If you have just X alone, it means that is 1X. If you have, say, let's see, if you have just, say, X square, we know that 1 is supposed, we don't have 1 in front of it, but 1 is really there, okay? So it is understood to be there but never written. So B is what? 1, A is 1. So the answer then would be, what would be the answer? Minus B over 2A. What would be the answer, guys? Tell me. Minus B over 2A would be what? Both of them are 1, so what do we get? X equal to minus B, which is minus 1, divided by 2 times A is 1. So the answer is negative 1/2. The answer is negative 1/2. That's the answer. Okay? X equal to negative 1/2. Any question about that one? All right. All right, now let's move on now, guys. Well, we're almost finished now. You know, so we're almost finished. We only have one question. We're finish after this. One question we finish. So I can't believe so I'm really finishing everything tonight as I wanted to finish. Now use a graph. We're going to use the same graph now above to determine the solutions of this following pair of equations. What do you call this equation? Simultaneous quadratic. Excellent. Simultaneous quadratic. It should be L. Simultaneous quadratic equation. Okay? It's called a simultaneous equation because there are two equations. It's simultaneous because you're trying to solve for x and y at the same time. Quadratic because we have the I power being 2 in one of the equation, the I power being 2. So one equation is linear, one is linear, and one is quadratic. We can solve this by substitution, by the way, but they want us to use the graph to solve it. So we're going to draw the graph of y equal to 2x plus 4. So what's the graph of y equal to 2x plus 4? And we're going to use it on the same grid. Same graph paper. We have this graph already. So what they want to know, they want to use the same graph to show where the two graphs meet. Because where the two graphs meet will be the solution of the equation. All right? So let me know, guys. The graph of 2x plus 4 is what? Where does the graph cut the x-axis? That's where y is 0. Is that sketch, you know? Where does the graph cut the y? Where x is 0, right? But guys, did you know that? If you have y equal to mx plus c, did you know that? In this equation of a straight line, c represent what? The vertical intercept. So the graph cut the y-axis. So in this case, our c is 4. So the graph cut the y at 4 right here. So what is x now? Where does it cut x-axis? Where y is 0. When y is 0, what do we get? We get 2x plus 4. You bring over the 4, you get minus 4 equal to 2x. You divide 2 by 2, x equal to minus 4 divided by 2. So x equal to minus 2. So the graph cut the x at what? Minus 2. Okay? Right here, so. It's a straight line. We just need 2 points. So you're going to draw your 2 lines together like that. Okay, guys, come Gina says now, walk with me. So you join the line together as one line. I go all the way up. I know you're going to pass through 10. You know why I'm not going to pass through 10 right there? Because I actually did it manually first to confirm my answer. I made these two y's are equal to each other. I made these two y's equal and I did substitution and I know that it cut it at 10. So when I say use the graph to solve the equation, because you have the graph of the two equations, the solution lies where the two of them intercept. They meet right here, so, and right here, so. So what are the solution? The solution is where the two of them meet. You go down in your exam with the ruler and you extrapolate. You call it extrapolation. You go down, read off this number here on the x-axis. That is your x equal to 3. Here, it meets at minus 2. So the answer is x equal to minus 2 or x equal to 3. So that's the solution of the equation. If you want to do it the way I suggested, you can equate for y. You can make the both of them are equal. You can make both of them equal to each other. If I can shift what time I have one question leave, guys. So if you want to do it the way I suggested a while ago, it's called simultaneous quadratic equation. We can equate for both y's. So anyway, so y replaced by whichever one you want to use. So we can go to these two equations. Y is equal to both, so we can equate for these two. So I can replace y by 2x equal to 2x plus 4. So in the first equation, I can call y 2x plus 4 because that's what y is equal to in the second equation. So we call it equating for y. Same as what substitution we're using, okay? I'm going to get the same answer I got a while ago. It's now a quadratic in what? In x, I bring it on one side. Everything in x on one side. X on one side, everything on one side. So I put it in the form of ax squared plus bx plus c. I bring everything on one side and I can now factorize. So here comes again factorization, come back to aunt you. So x minus 2x is minus x. And this will get minus 6. And you can now factorize, yes. That's going to be the issue with some people cannot factorize, I realize. So we get x and x. What time is it now? All right, I know what time is basically almost up. I won't be able to teach you factorization again as I wanted to. So and that's what they get x equal to 3 and minus 2. Because this will be equal to 0. When I factorize, I make both of them equal to 0. Or this will be equal to 0. And both equations now, x will be equal to 3. If I bring it over, I get equal to 3. X equal to minus 2. I get the same numbers that they get on the graph. X equal to minus 2 or x equal to 3. And that's it. Any question about that, guys? Guys, I wish I could teach the factorization in detail. It's a long topic, hard to teach because I have to show you by inspection and you have a long way and a short way. There's so much parts to have. There's only 2 parts to finish. Maybe I can teach them. I will ask Mrs. Johnson for permission because I know we're supposed to finish by 7:30.
Go ahead. You can continue, Dr. Morgan.
Thank you. Yeah. I think I want to show them factorization because I know it comes up everywhere, So I want to make sure at least before I finish. This only has 2 parts, so basically we're going to finish in time. Thank God. All right, okay, guys. So you need to know the difference between a speed or a velocity time graph as opposed to a distance time graph. The key is that, guys, for a distance time graph, it looks like this. What you will see on your vertical axis tell you what it is. Yes, yeah, man, look at your vertical axis and it tells you what it is. If you have meters alone, meters no per second, just meters, then it's a what? A distance time graph. Yes. All right, so those that didn't come on Tuesday, let me explain to you the difference between both of them now. Okay, you have 2 types of time graph that CSEC requires you to know, okay? You have a distance time graph. So can I use a different space to write? I need some space to write. Can I get some space? Let's use it right here. Okay. So if you have on your vertical axis, if you have just meters alone, meters. If you use kilometers or whatever they use, distance they use, but you're not going to say per second. You're just going to say m alone, m, no per second, just m. And of course, it's going to be time. Of course, time. This will be time, which I might call s, seconds. So if you give like the kilometer, they're going to use kilometer per hour. Or if you give what? Meter is meter per second. So kilometer per hour or meters per second. This is your time. No, sorry, distance. So on your distance time graph, as the name suggests, the vertical axis represents your what? Your distance. And the horizontal axis represents your time. So for the distance time graph, which is this distance time graph, this part of the journey represents your uniform, same as what? Uniform is same as what? Constant. Uniform velocity. It's called uniform velocity. Okay? This part here represents the body is at rest. The body is actually sleeping. The body not moving. Body at rest. So they use the horizontal line to represent what? No motion. No motion. Body at rest. So it's that move. It move like it's actually stationary. Okay. This part of the graph is same called uniform velocity. Same thing, but going in opposite direction. So both of them are called uniform velocity. Okay. No, but our question is not that. Our question is different now. Let's look at our question. Our question has here what? Per second. So this is called what? A velocity time graph. Not distance. Time graph. All right. Cool. All right. So therefore now guys, so on this now, oh sorry, my mic is muted. So for the velocity time graph, guys, let me tell you what this represents now. This part of the journey represent uniform acceleration, right for me? Uniform acceleration, or constant, use uniform or constant acceleration. Yes, that's right. Yeah, write it properly. This part of the journey represent uniform velocity. Yes, uniform velocity. Constant velocity, not moving. No, sorry, I'm wrong. Let me say it the right way. No, acceleration is the change in what? Velocity. All right? The rate of change in your velocity. So when it accelerate, it tells you the change in your velocity. So it's uniform what? Velocity. Cool. So uniform velocity. This part of the journey represent what? Uniform deceleration. Uniform deceleration. Or people call it retardation. It's the same as retardation or what? So deceleration is the same as retardation. Retardation or deceleration. Deceleration or just write for me, guys. Deceleration or retardation. Okay. I need to move on quick now. So we're asked to find then. That's our journey. So the following diagram shows the velocity time graph of a car's journey from town R to town Q. The car accelerates for 2 minutes. So guys, so 2 minutes is like, they put seconds, right? So that's be 120 what? 120 seconds, right? So it goes for two minutes. And then now it says now, travel at a constant maximum speed, then slows down. So the part of the journey that they're describing, ladies and gentlemen, let me erase everything here now, not to confuse you. Come Junior says no. Walk with me, pay attention now. So the part of the journey that they're describing to us is this part first. So the uniform acceleration is this part, guys, that we just established a while ago. This part is uniform acceleration. All right? Uniform acceleration. So what it does now, it says it's actually what? It travels at a constant maximum speed. This part is uniform what? Velocity. That's the constant speed they're talking about, the constant speed right here. Yeah, it doesn't. The speed the speed doesn't change, it remains the same. Like the car is driving. Think about it practically. The car is driving and it keeps changing speed. That's why I say acceleration is a change in the velocity. You keep changing the speed of the car keeps going faster and faster. So the velocity is what? The change, it keeps changing at a certain, the acceleration is a change in your speed. In your what? In your velocity. Because we call velocity speed. And then now, when it decelerates, it starts slow down. All right? But it starts slow down at a type of speed as well. If it remains at the same speed, you're driving 50 kilometers per, just keep at the same 50 kilometers per hour. It doesn't change. Like it going on in some like zone and police is there and it's a 50 kilometer zone. You want the car to be at 50, it's constant speed, okay, uniform what? Velocity. But what they want us to find now for part 1 is the initial acceleration of the car, which is this part here. Everybody appreciate that? This part of the journey. Everybody appreciate that? That's uniform acceleration, that part of the journey. So what you have to do, guys, you have to know complete a right angle triangle. Yeah. Right here, so. See it here? Like that, really. Why? Because acceleration is what? The change in your what? How do you find the uniform acceleration? The change in your speed or change in your velocity over what? Over change in your what? In your time. Everybody following me? So the formula is what? The uniform acceleration represent, and same as deceleration, guys. Same for deceleration. You find it that you find actually the gradient of the line, Yeah, you find actually the gradient of the line, you know, is the vertical rise over the horizontal run. The rise over the run. So it's the distance divided by the time. So acceleration, I think I wrote it wrongly, is equal to the change in what? Right, from a change in what? Your speed divided by change in your time. Change in your speed divided by time. Change in time. Guys, I'm not writing properly at all. Just write quick for me. Change in your speed, change in your time, right? Change in time. So we are focusing on only this part of the journey, from here to here only. We don't care about anything else. This part we want. That's the part of which talk about uniform, okay? So what's the change in your speed? The vertical rise over the horizontal run. The vertical is what? From here to here, from 0. So it is from what? So it's 30 to minus 0. That's the difference in what? In your speed, is it correct? Change the distance from here to here is what? 30. Are you guys following me? Are you guys following what I'm saying? You guys sign off on me? What is changing your time? Look at this part of the triangle, guys. The triangle. From here to here is what?
Oh, they're not sleeping because I'm not seeing any responses in the chat either. Students, remember you can open your mic and speak with sir.
It going up by 60, I realize. It going up by 60, thank you. It going up by 60, 120. Yeah, that's what I was asking. So I want this point right here. So from here to here is what? So just write yours properly in your book for me. I cannot manipulate my mouse properly at all. So it's 120 minus what? Minus 0. Yeah, 120 minus 0. So from here to here is 120 really. That's what I'm saying. It's 120, right? 120. So the answer is what? 30 over 120, which is equal to? You can use 3, 30, I mean 4. You got, is it 1 over a quarter? Is it 1 over 4? Yeah, 1 over 4. So you can keep it answer that in the exam or use 0.25. So it is 0.25 meters per second square. Which is what? Acceleration is what? Second square. You cannot say per second. That would not be acceleration. For velocity or speed is per second. But for acceleration or deceleration is second square. So it's 2.5 meters per second square, written like this. And that is your uniform acceleration. If you ask about deceleration, you'd have used this part of the graph, guys. For deceleration, you'd have used this part of the graph. And if you find the gradient of that line, it will be the vertical rise over the horizontal run, and I get that answer, okay? All right, the last part now asks us now for your calculate distance between the two towns. Those that are there on Tuesday, who can remind me now, how do you find the distance between on your time graph? How do you find the distance traveled? Who can tell me what to find? To find the distance traveled, it be what? Who can tell me what do I find? If you're here on Tuesday, the distance traveled is represented by the area under the graph. The area, you find the area under the graph. The area. Yes, they find the area under the graph. But the graph is a trapezium. No, let me say the right thing. The figure, not the graph. The figure is a trapezium. Yes, a trapezium, guys. So I'm going to find the area of the trapezium, and that area represents the distance traveled. Yes. Guys, see, is that a trapezium? Those who are here on Tuesday, or if you weren't here on Tuesday. Guys, let me show what the trapezium look like 2 different ways fast. And I know I'm going to do factorization soon. This is your trapezium like that. That's a trapezium. It can look like that. Or it can look like this. It's still a trapezium. Take 2 different forms. So this is your trapezium. So we're going to find the area of that trapezium. So the area under this graph, this area here represents what the distance traveled, the area of the trapezium, okay? What's the area of the trapezium? Who can tell me? 1/2 of the sum of the, what's the area of a trapezium? 1/2 times the sum of the parallel side times the perpendicular distance. Is 1/2 the sum of the parallel sides. What are the 2 parallel sides? So guys, come again. If you have this and this, that's a trapezium, right? What 2 sides are parallel? These 2 sides are parallel. Call it A and B for convenience. This is B. And if I have a height, let's put a height right here, a vertical height. Call this H, the height H. So the area of the trapezium is given by 1/2 the sum of the parallel sides, so it is A plus B, because those 2 sides are parallel, times the perpendicular distance, which is what? H, or the perpendicular height. We don't use the slant height, not the slant height, because we don't use the slant height, the perpendicular height, which is H, okay? So in this case, here is what? One side, this side is parallel to this side. So what's the area? Help me now. So the area would be equal to 1/2 the sum of what? This side is what? All right, this is 120 seconds. That's 120. It goes to here to here. So it's what? No, what's this side, guys? Is this 600? Yeah, 600. So the length of this line is what? This length, I'm finding that length from here to here is what? Is it 600 minus 120? That give me the length of this line. What is 600 minus 120? Is it 480? 480? So this distance is 480. So it's 480 plus this distance at the bottom is what? From 0 to what? To? This is what? This is what is plus 60 is what? What is 780 plus 60? Okay, you keep going by 60. Is it 840? Yeah. So that's plus 840. What's the height at the trapezium? Is it 30? 30. And that's the answer, whatever the answer comes to. And the answer should be, this is 30, it should be 19,000. When you do the algebra, use the calculator, you get 19,800. But because you find distance, it's meters. Okay, that's the answer. So it's 19,800 meters, and that's the answer. Okay, guys, I know some of you sign off on me a long time. All right, so before I leave, guys, let me just remind you about factorization, and we can leave, and that will be it. All right, so take a picture for me quick. Take a picture. So it's 19,800 meters is the distance, okay, which represents the total area under the graph, which is the distance traveled from town R to town Q. Okay. All right. Lastly now, guys, let's move on to factorization now. So let me remind you how to factorize, guys. I'm just going to remind you to factorize now quick. And we can call it a night. Let's use this page here. So first things first, guys. So whenever you have what is called a expression, which is called quadratic expression, if it take this form, let me show you the form that I want you to know now. If you take this form, so we can factorize by inspection, okay? Come junior students now, pay attention now. Statement guys, almost done. if you have ax squared plus bx plus c, you can take that form. If you take this form, if you take ax squared, this is done by inspection. I call it by inspection. Minus bx minus c. If you take this form, so you basically know what you're going to get for the answer. So if I'm marking CSEC maths, I can actually look at the answer and know, without even doing anything, I can look and see what a student has by just looking at what I know I'm supposed to get for the answer. So I don't have to do any long thing. I just know if it's right or wrong by looking at it one time. Students always ask me, Mr. Morgan, how do you know that the answer is correct by just look at one glance? Because I use this concept. So if this is your expression, you take those 4 forms. Now, if A is greater than 0 mean positive. When you factorize, if you have 2 plus sign, if you have a plus sign in front of the B, a plus sign in front of the C, you're going to always have 2 plus sign in the answer. You're going to always have 2 plus, sign. Did I say sometimes? Did I say sometimes? Always. If you're a minus sign here and a minus sign here, in your answer, you're going to always have a plus and a minus. Or minus plus. One bracket have a plus sign, one bracket have a minus sign. If you have a plus sign in front here, a minus sign, then it's going to look like the same we did a while ago, which is plus and minus, like that. It's called inspection. If you have a minus in front of the B, plus in front of the C, then you're going to have 2 minuses in your answer, 2 minuses. Okay, it's called inspection, okay? So let me give you an example now. Quick now, if you have now like x squared, for instance, plus say x then minus say 12 to factorize. Which one of those always look like? Is it the first, second, third? Well, is it this one here? Is it this one here? Which type is ours? Is it this one here? Or is it this one here?
The third one.
The third one. This one here, not true? Excellent. So that means your answer must look like this. Plus minus, right? Agree? Agree, right?
Yes, sir.
Now, to factorize that expression, this is what you have to do. You must say what and what give us x squared. What and what give us x squared? Is it x and x? Yes, because guys, this method move like a bullet. It move like a bullet. It don't waste time. What and what give us x squared? X times x. So you only say what and what give us the first number. What and what give us the last number. It can be 6 and 2. It can be 12 and 1. It can be 4 and 3. What combination are you going to use? If you try 6 and 2, then when I subtract or add, I must get back a plus 1. This the number in front of the B or the x, I must get that same number. So that's the trick, you know. What and what give us minus 12? And if I add or subtract, I get 1. 6 and 2 can't work.
4 and 3.
It has to be 4 and 3. It can't be 12 and 1 either. Because 12 plus 1 is 13. 1 from 12 is 11. We want to get a 1. So this one give us a what? So it has to be a plus and a minus right here. Because 4 times minus 3 is minus 12. And 4 plus minus 3 is plus 1. So you factorize. And if you expand, you get back where you're coming from. That's a short way, okay? I will show you a long way and call it a day. I will show you the long way and that's it. If you don't know that way, let me show you the long way that CSEC also requires, the long way. The long way, which I call long way, you're bringing what is called factorization by grouping. So take a picture fast for me and I will show you the long way and we'll call it a day. The long way. I know I could have done more example, but I don't have the time and, you know, because I have to go and, you know, you guys have to go as well. And it was, you know, it was really a good session, guys. I really appreciate and enjoy teaching you guys. Yes, I'm just sorry that I cannot teach you guys again for now because the time constraint and all that, and I'm marking exam papers and all of that. So the long way now, guys, which I consider the long way, is to have it like this. We have what is called the product and the sum. This general form is called the expression, quadratic expression. We form what is called a product. This is called the product. You multiply this by this. That's the way I show my CSEC student. When I taught CSEC back in the past. We call it the product. And this is called the sum. So if you don't understand the short way, this way is always the way to work. This way work like a charm. Can't go wrong. You multiply a by c. So our example now is x squared plus. Guys, I just made up this example here that I made up came from nowhere. By the way, guys, this example here that I made up came from nowhere. I just make up an example top of my head. Ready now? So we're gonna form our product. What is our a in our case now? What is our a? Our a is what? Is it 1? 1 is a. What is our b? 1. What is our c? Minus 12. Okay. We'll multiply 1 by minus 12. We get minus 12. Yes. You put somewhere like this, like a little T account. Now, when you get minus 12, whatever number you get, when you multiply this by this, whatever number you get, guys, you put it somewhere. And you say, now, what give us minus 12? What time what give us minus 12? And when I add those two numbers, all right, you cannot do both of them at the same time. It's either add or subtract. If I add them or subtract, I get what? I get 1. I get the sum, which is called 1. That's called the sum. This is called the product. What are the two numbers? Multiply, I get minus 12. I get 1. What are the two numbers? Is it 4 and 3 or 4? Is it 4 and minus 3 or minus 3 and 4? I mean minus 4 or 3. Is it 4 and minus 3?
4 and minus.
Yeah, that's the numbers, okay? We can't try 6 and 2 or 12 and 1. It has to be the two numbers have to be close. Because I want to get 1 for the difference, okay? Our sum. So minus 3 plus 4 is what is 1. So when you get those two numbers now, what you're gonna do now, guys, to bring it to this conclusion now, this is what you have to do when you finish now. So the only reason I did this a while ago is to replace the middle term. You must replace the bx term by those two numbers. Yes, that's the only reason you found those two numbers a while ago. So you found those two numbers for only one purpose. It's to replace the x term by those two numbers. Your x term is 1 and it's 1x. See there, 1x. You replace it by those two numbers. You replace this thing here, look. You replace this here by those two numbers. So you write it as x squared. Oh, let me just change the mark again, sorry. You write it as x squared, guys. Come, Junior says, welcome me. You don't replace, you don't write back 1x. 1x only replaced by 4 and minus 3, but we call it 4x. The reason I put an x beside it is that you're replacing a term in x. So if I replace 1x by these two numbers, I get 4x minus 3x, which give back the same 1x. Don't just give back x. Don't I get back x at the end of the day? I get back x for both of them when I combine them. Don't. Right, guys? So you actually, so the old purpose is to put it in a different form. But you must get back where you're coming from. You must get back the original expression. Then you factorize by grouping and you finish. Yeah, anybody remember grouping? Grouping says that you group the first term with the second term, and you take out the common factor. The first term and second term are these two terms. What's the common factor? Are there any number factors? No. Letter factors, yes. X, excellent, very good, X. What is left? X plus, is it 4? That's the first two terms, right? Is it that? Is that 2? Yes? Yeah, man. Because if I expand, you get back what? X squared plus 4x. The third and fourth term now, similarly. But all grouping works is that whatever is in this bracket here, guys, you must get the exact thing in the next bracket. You can actually close the eyes and write it. You can close the eyes and write it. Whatever is in this bracket here, you must get the exact thing in the next bracket. Exact thing. Yes, this will not be correct. We don't even know what goes there. I know that it has to be the next factor. The same exact thing. So if I take out the common factor between minus 3x and 12 and minus 12, I put it at minus 3, which is the number factor. There is no x factor. I mean there are no letter factors, only number factor. Is that true? Is that minus 3 goes there? Yes. Because minus 3, let's write it properly. Let's write it properly now. And that's the final thing. X plus 4. Is it true? Let's say it's true. Minus 3 times x is minus 3x. Minus 3 times 4 is minus 12. So it's properly factorized. Then now you factor it one more time. You take out one more factor. What's the next factor? You take out. What is common to both? What is common to both terms? What is common? The factor is what? X plus 4, right?
X.
So you take out the common factor. And what is left? What is left? X minus 3. School is over. And that's a factorized by what? I call it the grouping way, by grouping. Because why do you factorize in mathematics, guys? Why do you factorize? The final thing I will say for the night is that the reason why I factorize in mathematics, guys, is to reduce an expression from the given number of terms to just one term. Initially we had 4 terms. We had 4 terms right here. When you factorize the first time, we get 2 terms, and you only get 1 term. You might say, what is 1 term? Because what separates 1 term from another, if I have a plus b, that's 2 term. A minus b is 2 term. A divided by b is 1 term. A times b is 1 term. So what separates 1 term from another is a plus sign and a minus sign. It's never the multiplication or the division. So a times b is 1 term. So initially you had 4 terms separated by plus and minus sign. Then you have your 2 terms. Then you only have 1 term. This is 1 term, but 2 factors. So in the factorize, you must get only 1 term. Okay? All right, ladies and gentlemen, I'm sorry that I cannot tell you more things about factorization. But guys, that's it for me. School is officially over for the night. That's it.
Thank you, Dr. Morgan.
Yes,
Thanks,
Mrs.
students, for staying with us. Students, can you give Dr. Morgan thumbs up, send some hearts to Sir? Sir
Thank you
would
very
have
much.
been here with us on Tuesday, and
Yes.
he's back with us today. We really want to say thank you to Sir, and let me just give you all an update. Next week,
Yes.
Tuesday, we will be looking at question number 7. So we're going to be looking at some past paper questions that are linked to question number 7 on the CSEC math paper. This is, you should all know, pattern sequence series. So you know that that's one of the questions that sometimes, especially as it pertains to the general rule, you may be unsure. So please come back next week, Tuesday, when we will look at pattern sequence series. That's question number 7. And then our final day will be next Thursday, when we will look at past paper questions coming from number 6, which deals with measurement. Now, I really want to say thank you, because all have been here from the very first session. You're still here with us. Have a wonderful evening, everyone.
Thank you very much.
Dr. Morgan, again.
You're welcome again, Mrs. Johnson. Thank you very much. Yes, for having me. And thanks, students. I wish you all the best for exam. It was a pleasure teaching you guys. Yeah, man.
Great. So we're going to close the room now.